So people frequently, as part of their planning, forget that you probably have a whole bunch of documentation that's out there, whether it's security policies or disaster recovery or acceptable use policies or whatever, that all talk about your old physical architecture. And those boxes and boundaries and stuff probably don't exist any longer. And we need some kind of map that's going to let us understand the organization and planning and stuff that's here. So as part of all of this, it probably means that it's one of those fun times when we get to pull out all of those documents, blow the dust off of them and how they were originally written and decide if they're staying in our current environment that's there. Again, with limitations on here, the thing to realize is that, again, not every single thing that you want to do is necessarily a good match for virtualization. So again, servers with a huge memory or processing needs probably, don't fit into that circle here. Security is the other item, and that's, again, one of the major topics that was talked about on our slick here. Okay? There are simple things here that we want to take a look at. Your relationship between your system of administration and ownership and the operating systems that are there changes fundamentally with virtualization. I can point to a given server in a virtual environment that's on there, and again, there might be 10 or 15 instances of different operating systems running there. They're all running through the layer that's called the hypervisor. It's the piece that gets installed, actually owns the hardware, and mediates access for all the things that are running on top of all the guest operating systems. Okay. So that hypervisor then is a point of concern in your organization. In VMware, when we install, there's a root password that's created as part of that installation that allows access administratively to that, so we can do things like, set up the environment initially, attach it to Virtual Center, do other things. In Windows, when we do an installation on here, the Server 2008 system that's going to have hypervisor edit, or the Hyper-V edit as a role here, obviously has an installation of Server 2008 that's sitting there. In Zen Server, we have an installation of Linux that's done there, and then the hypervisor is added to that. And so securing of those systems is critical. That system on Hyper-V is called the parent partition. For traditional ESX systems under VMware, it's called the console operating system. And in most Zen systems, the partition that controls the hypervisor is called DOM0. Now, all of those systems are more or less full-blown operating systems. In Windows, it's more so because, there's an entire Windows system there. In VMware, the console operating system on there is a modified version of Red Hat. Okay, actually, it's a modified version of CentOS, which is everything that's in Red Hat Enterprise Server minus the 4 license packages that are there. So it's a version of CentOS that's on there. There's a tendency for people to become dissociated because they interact with the virtual machines on a more daily basis, to get dissociated from those operating systems that are in control of things and forget to do things like change the root password. So when you installed all of your ESX systems, you probably didn't generate a new root password for every single one of them. That means everybody who is involved with initial deployment has access to that administrative account unless the password is changed. And they have access in perpetuity, meaning they leave your company and, come back a couple of years later as a consultant. They go, gosh, I wonder if they changed the root password on the account. No, they didn't. Look at that. It's the same password on there. Okay? That account can do everything. You go, well, that account can't block it from being able to be used across the network. So we can go ahead and block that. That's true. It doesn't block me from physical access. So if I can access the console on the server, I can still log in as root. And, they can't log on through Virtual Center. True. That's a high-level management tool. It's effectively the management proxy in the VM world. Right. But I can log on via the local physical console or go ahead and log directly onto the server just using the vSphere client. And I can go ahead then manage your ESX host and do everything that I can do directly from those tools, which is pretty much everything. So I can't clone or template. I can't initiate a vMotion from the vSphere client. I can from the console if I can get physical access to it. I can rip your networking down if I'd like, disconnect all of your vSwitches in the environment, go through and format the data stores that are found on this and destroy all data. So I can be reasonably destructive from that. So when we're looking at that, security-wise, all the stuff that you would normally deal with, dotting your I's and crossing your T's on the system. If I'm installing Windows, that local administrator account is always a concern. So that means in Hyper-V, the parent partition is a copy of Server 2008 that manages that local Hyper-V instance, and its local administrator password is more concerning than just the average Windows box, because now I'm hosting multiple guest operating systems that are there as well. If I can log on as administrator, I can launch the Hyper-V administrative tools and go and have fun here again. So when we're dealing with security, the simple stuff. Physical security of your virtual servers is more important than physical security was for your standard physical servers, because access to any one box is access then to all the virtual machines that are running there at the moment. So that one seems pretty straightforward. Networking. You got to understand how networking works in a virtual world here. There's lots of things that are being done in and out of your virtual servers, whether it's, again, ESX or Hyper-V or XenServer. There's management traffic. That's the stuff that we're going to, log into the pretty graphical pages and do most of our management with. You probably want to isolate that stuff. You probably want to not have it run across your normal production network. You go, oh, it's encrypted over SSL. What's the big scare here? Okay. You really, if you want to look at security stuff just in general for networking, take a look at the topics that were up for discussion at last year's Black Hat conference out there. SSL, man-in-the-middle type attacks were rampant out there. CA certificate spoofing and stuff all over the place here. So when we're taking a look at it, it's way easy to go ahead and if you're just not paying attention, to go ahead and stick my stuff between you and what you think is a secure system managed by an SSL relationship. So simple stuff. When I first launched my management tools to go and launch Virtual Center, for example, on VMware, I get a dialog box that indicates that it doesn't trust the certificate that's being given to me. That's a big no-duh because it's a self-signed certificate from the local Linux console operating system on there. Okay? Most administrators then go, well, duh, I expect it to be untrusted because it's a self-signed certificate. They go ahead and check mark the import certificate, hit the ignore button, and move on. Okay? I would recommend you that you just bother, there's a little details button there, look at the cert. Okay? You're trusting an unknown certificate unless you actually look at what that certificate is. Man-in-the-middle attacks on SSL are stupid simple to do. You probably have a firewall in-house that does SSL intercept right now. SSL intercept is SSL man-in-the-middle. It ends your SSL conversation from the client on the firewall and starts a new one on the outside with the SSL site and allows you to see all of the traffic in the middle and inspect websites and stuff as the firewall in the middle, okay? If I can do that on a product right now that's in your environment, then it is stupid simple to go ahead and do the same thing on a Linux system where I want to hack into your network, and SSL man in the middle is really, really simple, especially if you're not looking at certs. So just look at the cert, hit the details button. What does it say? It should be a VMware self-signed certificate on there. If it says it's owned by Linux at or localhost at domain or something like that, it's like, I don't know, that doesn't sound, this one will have an actual VMware self-signed branding all over it, indicate that it's being used for those purposes. So just simple stuff like that. Management traffic is pretty easy overall. In a VMware environment, for example, it's 443 for SSL traffic. It's port 22 if you're going to go ahead and use SSH on there. But people often forget that there is, for hosts that are being managed by Virtual Center, there's an additional port 902 over UDP that's used for heartbeats effectively between the local host and also the virtual center system. So if 902 isn't open, it's not a security issue, but your systems will drop out of virtual center. You'll connect initially over 443. Everything will be good. We'll go ahead and set up the management client within the console operating system, and then they'll die a couple minutes later. It also means, though, that if I want to go ahead and hack hosts out of virtual center, that's a port that can be attacked as well here. So if I want to go ahead and cause you issues in management on here, 902 UDP. So again, the general suggestion is that's a management port. That's not a general network traffic port. It's not used by users to go ahead and connect to these systems. So that traffic should be controlled and made sure that it's going to go ahead and be handled over private VLANs or stuff where users will have a hard time to manage. That means managing routability into those VLANs that we're using for administrative traffic is another thing that you're going to have to do, because if it's just, if I am able to determine through whatever means what subnets are being used there, I can attack that traffic across the router the same way I can if I'm local to it. So it means also managing routability into those domains as well. Okay. So, hypervisor. Okay? This is a scary piece when you think about it, okay? Because the hypervisor is an operating system that sits on top of the hardware and effectively controls the relationship of all of your guest operating systems. So sits between the guests and the hardware, all communication, network, memory traffic, and all of that is handled through it. One of the burgeoning areas of IT vulnerabilities right now is looking at ways to attack the hypervisor itself. Okay? Now, we have to make that with somewhat of we have to look at this with somewhat of open eyes. First off, most of the hypervisors can't be managed directly, meaning that there's very little management that can be done. We normally have to attack whatever, so either the console operating system or the parent partition or DOM0 to attack those. But you guys are all, hopefully on the mailing list for all of your vendors and the operating system vulnerabilities and stuff, and you see every week new announcements of zero-day vulnerabilities. Execution of this vulnerability yields full administrative access to this operating system. Only known workaround at the moment, shut off these ports, and we'll have a hot fix out in a couple of days kind of stuff. Any of those can target these parent partitions and consoles and stuff just as easily as they can attack full versions of those operating systems running there. So that means harden your operating systems. When we're looking at this, people a lot of times look at that console operating system that runs on VMware, that CentOS, and they think of it like a Linux server. And they go, oh, cool, because I can go ahead and share out files on there by NFS, go ahead and set up Etsy exports, go through and turn on these services, set up SNMP, and do all. Okay, it's not a Linux distro. It is the management proxy for the hypervisor that's on that system. Okay? We're trying to decrease the attack surface on that. We're trying to limit the stuff that it does. So if we absolutely have to go ahead and make it part of SNMP, that's fine. Okay. But then again, those communities then should be controlled. We should go ahead and control the VLANs over which that traffic can be propagated. We should go ahead and control reachability for that. So all these things have to be looked at. You're trying to treat these things like they're special, not like they're general run-of-the-mill. Same thing is true for our parent partition in Hyper-V. It is a full instance of Windows on there. I can run IIS on there. I can install SQL and Exchange on there. Don't, okay? It has a special role in the management of Hyper-V here. Its role is that of the controlling interest, the management interface to that Hyper-V instance. If you want to run those other applications, that's great. Run them in virtual machines. That's what the virtual machines are for, okay? So, other pieces here. As we go along, people say, well, so we've got more operating systems we have to manage. Because you now have to manage not only your guest operating systems, you have to patch and manage the hypervisor that's on there. You have to deal with whatever management interface is on there. You've got the additional application running on top of, again, System Center, Virtual Machine Manager, or Virtual Center that has to be secured and dealt with as well. But outside of that, one of the areas that was kind of interesting that came a part of this is as we moved on to traditional Intel-based servers with all these virtualization extensions and things on them, that your servers that you're running as normal physical servers can be attacked by installing hypervisors on them. Windows currently allows that, right? Server 2008, you can stick the Hyper-V hypervisor right underneath it, and it allows it to go ahead and act as a management proxy to the rest of the hardware. Linux has had it for, well, a long time. So with Zen, virtualization and stuff. So we want to take a look at and make sure that not only on our virtual servers do we go through and take advantage of that hardware, obviously, to accelerate virtualization. But if you've got physical systems that are not going to have that functionality turned on, turn it off. Okay? Just like if you're not going to have IIS running on a Windows host, you go ahead and remove that functionality. The virtualization extensions and pieces that enable virtualization are sitting out there waiting to be used. And if you're not going to use them, then someone's going to stick a rootkit or something on your system by an exploit that will do so. And that becomes insidiously difficult to detect because from the operating system standpoint, I don't look like I'm running on top of the hypervisor. I see your actual processor that's there, and I can allow pass-through to your actual network adapters so you see them, you're installing real drivers from all that kind of stuff. So it's really insidiously tough to determine when I've been usurped in that way and that there's something acting between me and the hardware.